Hello everyone, so today we're starting a new unit 5, which is solutions. Here is the table of contents. I know it looks a little odd, we're skipping a lot of days, so I want to kind of go over what we're doing those days and why they're not on the table of contents. So today you're going to do solutions intro and the solubility chart. Tuesday you'll do molarity and dilutions. Wednesday, you'll do molality in parts per million. Thursday, the 22nd, is the last day of the 9 weeks. So for that day, we are actually catching up on missing work. This is a good time for you to make sure you have everything done before now, last minute grades, so you can get that in for your 9 weeks. Because now that we are block scheduling, you only have this 9 weeks and next 9 weeks. That's it. That's the only chance you have to bring your grade up. So it's very important if you have missing work to get it done by that Thursday. Okay, so that's why that Thursday is not on there. Friday the 23rd and Monday the 26th is fall break. There's not even virtual schools on those days. It's free days. We get to relax, catch up a little bit on sleep. So exciting. So that's why you don't see anything for the 23rd and the 26th. Now the 27th, that Tuesday, we are celebrating Mole Day. You will see a whole separate assignment in this section where your Unit 5 digital notebook is and the daily questions are specifically for Mole Day. So you will do that on that day, and it'll be in a separate thing. The 28th, my in-person class is setting up their Halloween lab for Chemistry 1, so we actually won't be going over anything for this unit. So this will be just a good time for the virtual people to make sure you're caught up on everything, get everything done that you need to, since you already, or you should have already recorded yourself doing the lab. Okay, the 29th, we will be back in this digital notebook, freezing point and the boiling point. Now that Friday, the 30th, is when you will review. I will send out an outline of everything that'll be on the test for you to study. And then on the Monday, the 2nd, is when we will be doing a lab. Now your lab, you'll notice in this digital notebook, is going to be different than the in-person people, but hopefully I think you'll enjoy what we do there for supersaturated solutions. That Tuesday, the 3rd, is let me double check, is a staff development day. So students won't have school. It's just a day off for you all. I will be here working for staff development. And then Wednesday, so that will be another good day to review if you need it. And then that Wednesday will be the test and notebook check. So it's a little crazy. There's a lot of days missing. It is on purpose. If you have questions about what to do when, you can let me know. Of course, you can work ahead if you want to, but this will hopefully keep you from being overwhelmed with everything if you just kind of follow this pacing guide. All right, so just to kind of introduce you, we're going to start with the solutions intro. So your topic for this is solutions. Your goal is I can identify different parts of properties and solutions. And remember, as you are watching this video, if you still have it itty bitty on the screen on top of your digital notebook, you can, of course, use the magnifying glass in your digital notebook. You can also, if you click on this video and you see the YouTube symbol below, you can actually click on that and it'll open it in a new tab, and then you can kind of go back and forth through the different windows or different tabs you have open. You can also make this box bigger or smaller, whatever you need to do to be able to take your notes and watch the video at the same time. So the first thing we're going to talk about is a solution. A solution is a homogeneous mixture, which is a mixture that everything's mixed up evenly. You can't really pick things out very easily. So it's a homogeneous mixture of a solution, of a solute being dissolved in a solvent. And you might be like, I don't know what a solute is, or I don't know what a solvent is, but we will get over it. So Just hold your horses. So the solubility, which is the ability to dissolve, we'll talk about that later as well, of a solute in a solvent is dependent on different properties that we will be talking about. So for this, you remember you just need what's underlined. All right, next slide. Oh, and a reminder, you can pause the video whenever to type out what's underlined. I do that. I don't really stop because I know you can pause it. So that's why I kind of speed through it a little bit, but I know you can pause it to give you time to write everything down. Okay, what makes up a solution? A solute is what's being poured into and dissolved in the solvent. It's oftentimes the smaller amount. The solvent is what's doing the dissolving. It's oftentimes the bigger amount. And it's what water is what your solvent's going to be the majority of the time. Sometimes it's other things, but most of the time it is water. Okay, different properties of solutions. We're just going to kind of talk about this a little bit. So for temperature, if it's a solid, as temperature increases, solubility increases, which means it could be mixed in a little bit easier. For gas solutes, as temperature increases, solubility decreases. For pressure, for solid solutes, the pressure increases, solubility remains the same. And for gas solutes, as pressure increases or gets higher, solubility decreases. Like dissolves in like, which we'll talk about more in the next slide. So if something is polar, then the only thing that's going to mix in or dissolve in it is something else that is also polar. If something is nonpolar, the only thing that'll mix in it is something else that's nonpolar. For example, water is polar. Oil is nonpolar. When we mix oil and water together, they don't mix. They're always separating. They don't like each other. They don't mix in with each other. And that is because one's polar and one's nonpolar. So in order for it to mix together, they have to be the same. And we've already talked about this a little bit. Solubility, it is the ability of a solute dissolving in a solvent. If it's soluble, it can. If it's not soluble, it cannot mix in. So certain factors that can affect the rate of the species dissolve is by increasing the temperature, by stirring it or agitating it, or crushing it into smaller particle size. It's very similar to rate of reaction, kind of the same factors that make an effect. So what is a solution? There are gaseous solutions. The air that we breathe every day is a mixture. It's a mixture of oxygen, nitrogen, and all sorts of other things. There are liquid solutions, and there are solid solutions. Now, solid solutions is probably not the most common. That's like your bronze and like the different metals that are mixed together. Liquid solutions, that would be like mixing lemon juice and water to get lemonade. Now, some solids will dissolve into liquids. Like if we pour salt into water, then we have salt water. It dissolves and it's in the whole thing. So you can also have a variety of different types of solutions based off the three phases. Okay. There are three types of solutions. An unsaturated solution, which means there can be more solute dissolved at that given temperature. You could still add more stuff. It's not to the max level yet. A saturated solution is a solution containing the maximum amount of solute that will dissolve at a given temperature. And then a supersaturated solution is a solution that contains more solute than would dissolve in a saturated solution at a given temperature. Now, supersaturated solutions, it's kind of hard to get those. What you have to do is you have to raise the temperature, put in as much as you possibly can at that higher temperature, and then once that temperature goes back down, it has more than what it should at that temperature. And the only reason it has that amount is because you raised the temperature in the first place. So for your digital notebook for this section, solution type, solvent, solute, and example. These are all kind of things we've talked about throughout this PowerPoint. Just a tip, your solution type will always be the same as your solvent. For example, we have water and we have salt. Water is a liquid, salt is a solid. Now we are pouring salt into the water, so our salt is our solute and our water is our solvent. Okay, so when we pour salt into water, it gets salt water. Now, is salt water a solid or a liquid? Well, it's a liquid, and that's because water was our solvent. So whatever your solvent is, your solution's going to be, or whatever your solution is, your solvent's going to be. So you can tell these two columns right here will always be the same. And then I want you to think of examples of when that happens. If you have any questions about this, let me know, and I will be happy to help.